record, okay? And then we are going to start to discuss. Okay, so we are going to continue our discussion about stack. And we already learned stack. So implement stack using array, is that you remember? Special, so stack implementation using array. Using array, as we discussed that, okay. And last class, we also discussed application about number conversion. That, and we discussed the example is from decimal number to binary number. Then we discussed the algorithm, and I showed an example that and using stack. Okay, so that example and the algorithm, how it works, we already know. So what today we will see is we will take a look at how to code that. Okay, so over here we wrote a function called convert to base x. Okay, so this is a decimal number. Decimal number, okay. And this x, we are going to output. This is a base. Yeah, base number. Okay, so it may be 2. That's binary. And it's maybe 8. It's an octal. And maybe 10. That's decimal. That can be 16. We call it a hexadecimal. So all of this, that's base number you can specify. Then this function can be used to convert a decimal number to a specified base, okay? So let's see, we need a stack. And last time we said that a stack is an integer stack. So we can use the stack that we implemented. So the algorithm, the first part is to fill the stack. And here is, you remember we are going to divide the number with the base. You remember we have 13, So you do module 2. And it's 1, and you push this 1 to the stack, and then you divide by 2, then it's 6, and then you're going to use 6 to module 2, then it's 3, Oh, it's not 3, it's 0. Module is 0. Then you push this 0 to the stack. Then 6 divided by 2, it's 3. We keep doing like this. So this is our number. So 13, 6, is a number. So the number is also updating. With integer division?
Oh, this shit, fuck that.
Integer division of base. Of the base. And within stack, what do you store? You store the module, the remainder. The remainder, you store the remainder to the stack. So that's the part. And when we stop that number updating, when it reaches 0, you're going to stop pushing the number to the stack. So that's this part.
So according to this algorithm, we can convert only to smaller bases, like to 8 or 2, right?
Hold on. There's someone someone like if someone is not unmute, please unmute. Okay. Yeah, please, Alex. I'm sorry, yeah.
So what I was saying is that we can use this algorithm only for bases that are lower than decimal, like 8 and 2.
No, 16
But
also. 16, we can also do it. Yeah, 16, you can also do it. It's not necessary to be decimal. Because think about it. Yeah, very good question. Is it 100? That's a decimal number, is it? But you want it to be hexadecimal format. Hexadecimal is base 16. That's also used a lot. One of it is is IP address. IP address, is it? And the MAC address, like in networking, is it? And the MAC address is hexadecimal format. And also, so hexadecimal, it's 0 to 9, is it? Then it uses A, B, C, D, E, F. It uses that, is it? So one joke.
Yeah, it works. Sorry, I messed up. It works.
Yeah. So that's just a joke. So because I also taught networking, okay, CS480 in the past. That's why I came to CIMO the first few years. And in MAC address, there is it's 48 bits. Okay, 48 bits, and 48 to 1. It's 48 to 1 in this case, is it? And the hexadecimal format is going to be F, is it? So students wrote on the board, oh, not me, so just making some jokes. Some professor give the students all one. Okay. Yeah, that's anyway, just some joking. Okay, so you can see that all Y is all F. Yeah, so that's just a funny joke. Okay, so that makes sense. So yeah, definitely, you see, you can also.
Yes, I don't know.
Like if you use 100 module 16, is it? So the remainder is going to be 0 to 15. Is it 0 to? So that's the beauty of the module operation. Is it module operation is applied to? So this percentage sign in CS is very, very useful. Okay, later on we will also see some ideas. It can help do wraparound a lot. Okay, so here basically you can see, like, for different number bases that we also use it. So quite useful. Okay. Okay, so let's continue. So that's the first part, is it? First part, you fill stack. Is it you fill stack? Okay, then next, let's see. Then we wanted to have our converted number, is it? Converted number, is it? Converted number, then how do we get it? Is then you empty the stack. Is it? You just get, in our case, is that 1101 for 13, is it? So you just get each of the digit out. Is it? So how do we do it? Oh, you use, that's what I said, with stack application, you use this a lot of this kind of loop. While the stack is not empty, then you do top. Is it? So here I want to output whatever the top is it? And you do what? Then you do pop. So you pair the top and the pop operation, and then you can get your task done. Okay, so here output the top then maybe 11, 12, is it, in a hexadecimal format, is it? That's why over here, because you're going to convert it to A, B, C, D, E, F, is it? So anyway, that so over here we use ASCII coding. Is it ASCII coding is 8 bits? Is it 8 bits? So it's the number from 0 to 127. Is it? So your keyboard basically all English letters. Is it English letters? The lowercase and the uppercase. And I remember it started with number 32. Okay, so you can double check. I don't remember exactly. So I remember 32 in ASCII code is lowercase a. Okay, lowercase a. And so anyway, so a code is there as. So this then can be represented as a letter. So that's how you do over here, because our hexadecimal start with A. Is it? So anyway, it can be the number. So here you cast it. Is it? So this will output the corresponding letter if it's other base. Is it other base? Okay, and also here you remember we have that try-catch block is because our top and the pop will throw the exception. So that's why here we use try-catch block. Okay, so that's this base conversion function. Okay, and then what next is another method called search an item. So here just try to show us how do we do search a stack. Is it? So this is an integer stack and you want to search a number. Is it? So over here, we don't want to change the original stack. Is it? So we want to keep original stack untouched. Untouched. Is it? So the way to do it, you can call stacks clone method. Is it? Then what over here is you get the top, compare with that number. Is it? If you find it, okay, you return true. Otherwise, you can keep doing. Is it? If the whole stack you empty out, is it? You still haven't found, then you return false. Is it? So this is pretty straightforward. Search, is it? So then in my example, then I showed, is it? So like this 1001 converted to binary, what it will look like, is it? And if it's converted to base 8, what it will look like. Convert to base 10, what it will look like. Convert to base 16, what it will look like. Okay, so after class, you can try this example, okay, to see what it look like. Okay, so that's regarding this example. Then let's move to the third example. So in our course website, it's called Java Stack Example 3, okay. So over here, we are not, if you take a look at my project, is that we just have this single kind of driver part, is a client file. We don't have our stack, our own stack. And over here, we import stack. Okay, so Java collection, later on we will learn, okay. So Java collection framework. So the library already provide, so it has a stack class. So you can also directly import it to use it so that you don't need to use my stack. And also this stack is generic. So you can apply this stack to any other data type, not excluded to just integer, okay? So then let's see, how do we use it, okay? Okay, so let's see. Over here, is it? Over here, what I did you see? I create a stack instance. That I do new stack. Is it? And you may see here, angle brackets, then integer. And then here we also have angle brackets. And who remembers where else do we also use this kind of angle brackets?
Array list.
Yeah, very good. Array list, is it? Yeah, we already, so I should capitalize. Array list, is it? Because whenever you use array, you need to specify the type, is it? Later on, we will know the reason, okay? So similar for the stack, if you want to use Java collection stack, then you also need to specify the type of the stack. Is it? In this case, you said, okay, it's going to be an integer. And also, be careful, okay? You may ask, why don't I just do this? Is it? That's not allowed. Not allowed, okay? So cannot parameterize using primitive data type. You cannot use primitive data type. That's why in Java, we call those integer, is it? And we also have double, is it? And the Boolean and the character class, is it? Those class are called a wrapper class. And who remembers those class, mutable class or immutable class? What's the difference between mutable class and immutable class? Okay, then that's going to...
Immutable cannot be changed, immutable can.
Yeah, okay, yeah. Okay, so anyway, just remember when we use stack class from Java collection, you need to specify the stack type, okay? So then next, this is our first quiz question. Quiz question, okay. So can you create a character stack object? Okay, and with a variable name, of course. Okay, character one this time. Over here, this is a integer one. I want you to declare, to create a stack that will hold letters, that can be used to hold letters. Can you write that single statement and send it to our chat? And using Java collection.
Do you use CHAR? Is that what it is? CHAR instead of the
think
full
about, can
character?
you use CHAR? Is CHAR a class?
No.
So the question, CHAR is CHAR primitive type or reference type?
Reference.
Yeah, very good. No, oh, reference? CHAR is a reference type?
Primitive.
Yeah, it should be this one. Okay, not a reference. Okay, be careful. Then who is the corresponding letters reference type? The reference type is who?
Objects like integer.
No, letter, for letter. I heard a girl just answer. Can you repeat?
Go ahead.
Yeah, I think that was Alex.
Is it character?
Yeah, Tuyen. Yeah, I heard Tuyen just answered. Yeah, yeah. So yeah, please, can you answer? Tuyen, can you repeat?
Is it a character?
Yeah, the complete name. Yeah, very good. Okay. Yeah, character. Okay, that's the reference type for letter, for single letter. Okay, so you guys should know how to write this, is it? Okay, so that's our first quiz question. Okay, then next, let's see. Okay, then what next we do is we create this integer stack. Then what we are going to do, we add 0 to 9 to this stack, 0, 1, 2, all the way to 9 to the stack. And if you use this stack, you don't need to worry about size. Not like our own defined ones, okay? You don't need to worry about the size, okay? So you push the number to the stack, then you can find if 8 is in this stack, previously we discussed how to search an item, and you can also output the whole stack, because it also has the toString method. That's why you can directly print out a stack, okay? And next, let's see, a very useful application also with the stack is you can use a stack to do, because stack is pretty good at reversing something, and over here you can reverse some sentence, reverse sentence. And then how do we do that? Is it like over here? Then you can also do check if it is palindrome. How do we check if a word is palindrome? Suppose like what's the good word? Suppose this may be Google's stock tick. I don't remember exactly, maybe, okay. So just like this case, is this word a palindrome? Yes, it is, because the first and the last exact same, the two middle all the same, So the palindrome is, so this is the original order of the word, and if it is reverse, you reverse it. And this is the reverse one. The reverse one, if both the original and the reverse one the same, then it is considered as a palindrome, So our next function is we try to reverse a sentence, then we can check if the sentence is a palindrome, So let's see, how do we do that? Okay, search an item, we already know, And let's see, here we have a utility function. We call it, clean sentence, clean sentence. So you plug in a string, So in that, so suppose you have a sentence, okay, hello, and you may have comma, and then you have 9, then comma, then word, something, and question mark, those. And in this case, this clean sentence will only keep letters and letters and digits. Okay, when we consider palindrome, we are going to not just consider those special signs. Okay, you only consider letter, alphabet, and the digit. Okay, so that's what we are going to check. So okay, we have a string, and over here I'm going to use a string builder. Okay, and with this string builder, I'm going to do letter by letter check. And how do you check if a letter is a letter or a digit? So the letter class, the character class, has a method called isLetter. It also has another method called isDigit. Okay, so you can use this two methods to check if a single letter. So this is, you get that single letter, from the string, So this is going to be 0, the first one. This is going to be the second one. Is it at 0, at 1, and at 2, something like that? Is it? You're going to check if it is. If it is a letter or digit, then you are going to append it to that string builder. Is it? And also I'm going to convert it to lowercase. Yeah, because when you compare to string, case also matters. Is it? So that's why you convert it to lowercase. And then you convert the string builder to string. So that's how you return to string. So you clean this sentence, okay? And it's a cleaned version. And then next, let's see. Then we can use a stack to also reverse the sentence. So here we have the string. And this time we have a character stack. Is it character stack? Okay, with this character stack, we can do the same thing. So this is a string builder. Is it? And we loop through the string for each of the letter. Is it? Okay, you add it to the stack. Is it added to the stack? And then I'm going to reverse the stack. So when the stack is not empty, you append the letter, is it, from the top of the stack. Okay, so in official stack class, the top method is not called top, it's called pick. Okay, so be careful, it's called pick. Okay, so it's changed, the name changed, okay. So in Java, for some reason, they like to name it as pick, okay. And so anyway, you get the top of the stack, the top letter of the stack, is it? And you append it to the reverse version of the string, is it? And then you remove that top letter out. So you keep doing until the stack is empty, is it? Then this is going to hold the reverse of the original string, is it? And then you convert it to a string, is it? And return it back. So that's how this reverse sentence method doing, is it? Reverse. So over here, we use an example. Is it, was it a cat I saw? Is it, I want to check? Is it? And then over here, I want to check if this sentence is a palindrome. Is it? And over here, we call this clean sentence dot equal. And then this is going to be the reversed one. Is it? The reverse of the original sentence, is it? So over here, you see, I use the dot equal. Dot equals method, is it? Instead of equal, is it? And why we don't use that equal, and we use this dot equal instead to check if both string are have the exact same sequence of letters.
Equal.
Yeah,
Check
please.
memory, doesn't it?
Yeah,
Memory.
yeah, very good. Equal checks reference. Is it over here? You only care about letters. Is it? Those are contents. Is it? Yeah, very good. So this is our second question. Okay, today's second quiz question. Question is let's see. Is why we use dot equal in this case instead of that equal. And then someone already answered, is it? So this is
Which of the methods?
Yeah, why over here for this palindrome check, we use dot equals instead of that equal sign.
Okay.
Yeah, what's the reason for this? So you just send your answer to the chat. It's because equal what? Checks for reference. Dot equals check for what? Check for contents. Contents in this case is all of the letters, is it? Yeah, so this is our second quiz question, okay? Can I erase this, all of this, clear them out? So that I can move to the next part. Okay, let's, okay. And then what next is going to be some new concept, okay. Okay, so we are going to discuss more application, is it? So over here, one of the application is we need to discuss is about, we call it postfix. Postfix expression. Okay, so what is the postfix expression? So let's see an example. Is it, so suppose I write 2 times 5 minus 7. So this is an arithmetic expression. Is it? So we all know this. And this is the normal arithmetic expression. Is it? So you have a parenthesis. Is it? And we also consider operator preference. Is it? Okay, so anyway, so this kind of arithmetic operation expression, we also call it in order expression. That is arithmetic in regular order expression. Is it? Okay, and what is postfix expression? Then in this case, it will look like something like this. 5, then space, 7, then space, minus sign, then space. Then we have 2, then space, then multiplication. Yeah, so this kind of expression, that looks kind of weird, is it? And but if we analyze, you can see you have 2 numbers. Follow it is an operator. Is it? So basically you are going to apply this operation to these 2 numbers. Is it? So that's going 5 minus 2, minus 5. 5 minus 7 is negative 2. Is it? So you can kind of cross this part. Then you have negative 2 and 2 and multiplication. Is it? So you have number, you have another number, and you have operator. Is it? And then it's negative 2 times 2, so it's negative 4. Is it something like that? So in this kind of expression, so I'm going to rewrite, so 5, 7, minus 2 and multiplication. Is it? So in this case, is it? There is no parenthesis. No parenthesis, is it? And it's always an operator following by 2 numbers. Even though you may say, oh, this multiplication, before it you only have 1 number, but actually this is a calculated result should also be applied when you apply multiplication. Is it? So this kind of expression, we call it postfix expression. Okay, postfix, there is no parenthesis, it's always an operator following 2 numbers. Is it? And but of course we still follow the operator's preference. Is it? So this is postfix expression. Another name it's called can I forget the other name? Postfix. Oh, the other, let me get it back later. Okay, when I recall, for some reason, it's just skipped out of my mind. So anyway, this is a postfix expression, is it? So the question is, how are we going to, so if you encounter this expression, how do you do the calculation, arithmetic operation on it? Is it? But based on what I just explained, it's kind of easy to understand. Oh, you apply the operator, is it on the previous two number? Oh, I have -2. Then you have other two numbers, then you apply this operator, is it? Okay, so visually for us, manually, we know how to do it, as if you have this kind of expression. But how can machine know how to do this if machine sees this expression? Is it so? That's the topic about stack application. Okay, so we can use stack to do it. So let's see. Okay, let me find a better example, okay, so that I can explain it better. So next, let's see. The expression looks like this, okay, 7 times 8, then -2 plus 3. Okay, so, oh, this is infix. This is, I'm sorry, for some reason I got it messed up, okay. Okay, so I need a postfix expression, okay, so that I can explain the algorithm. So I have 7, is it? And then I have space, I have 8, okay. I have space, and then I have multiplication, I have space. Then I have 2, and the space, and 3, and the space, and the plus, and the space, and the minus, is it? So write it short as 7, 8 times 2, then 3, then plus, then minus, is it? So anyway, this is a postfix expression. Is that expression? So now I wanted to calculate it. So we call it a postfix expression evaluation. I want to find the result. Okay, so let's see how are we going to do it? Is that how we're going to do it? So we can apply stack here. So here we have a number stack. Oh, number stack. So this is our expression, is it? So I'm going to do scanning from the left of this expression, is it? Okay, you're going to do one by one scan, is it? Because the expression separated by space, is it? Okay, so you scan we call it, this is the first token. So the first token, it is a number. If it is a number, I push it to stack. Okay, and then I move on to the next token. The next token is a number, I push it to stack. The next one is an operator. If it is an operator, okay, so scan from left, the algorithm, okay. So if token is number, okay, we push to stack. Is it push to stack? Okay, and next it's operator. Okay, if token is operator, okay, we are going to pop two numbers out of the stack. So 8, I'm going to pop it out. Then 7, I'm going to pop it out. And then I'm going to apply the operator to this two number. What do we get? We get 56. Is it? And I get it, I'm going to push it back 2 stack. Okay, and also be careful. You pop 2 number and you apply operator. Is it who is going to be on left, who is going to be on right? So the first number pop out is going to be on right of the operator. And the second number pop out is going to be on the left of the operator. For multiplication, the plus, it doesn't matter. But for minus, for subtraction, and for division, it will matter. Is it? Okay. So if token is an operator, you pop 2 numbers of stack and apply the operation. Is it? And push result back to stack. Back to stack. Is it? Okay, we can keep doing. Next is 2. And then it's 3. Is it? It's 3. And next is plus. Is it? So you need to pop 3 out and pop 2 out and apply it. You get 5. Is it? And then you push it back. I get 5. Is it? And then next is what? Is minus. Is it? Minus, then I need to pop 2 numbers out. 5 out. 56 out. And apply operator, I have 51. And then I get it back to the stack. Now, if you continue scan, there is nothing. It's the end of your expression. Is it? So your scan is going to be stopped. Okay, stopped. So when you complete a scan, so complete a scan, then pop the remaining number of stack. And that number, is it? Is the result. So you pop 51 out. So 51 is this postfix expressions evaluation result. Okay. So that makes sense about this algorithm itself.
So this algorithm is without parentheses, right? Like the curly braces.
Yeah. I have code for this algorithm. You don't need to worry to write it, okay? But I'm trying to explain how this algorithm itself works. So do all of you already understand this algorithm itself? Any questions about this algorithm? Okay, we can try another example, okay, to get familiar with this example, with this algorithm, okay. So the other one is 3, then 6, then multiplication, then 5, then 7, then 3, okay. Then minus, multiplication, and plus. Okay, this is a postfix expression, okay. But the precondition here is the postfix expression itself must be correct. Because if it's wrong, that algorithm won't give the correct result. Okay, be careful here. Okay, so let's review how we do this. Okay, so we are going to have a stack. So 3, okay, push it to stack. 6, number, you push it to stack. Multiplication, so you pop 2 numbers out. Apply the operator and push it back. 18, is it? And then push it back, push it back, push it back. Is it? Okay, next, it's minus. You pop 2 number out. it's 4, is it? And you push it back, okay, 4. And then next multiplication, you need to pop this 2 number out, 4, 5 times, it's 20. Then you push it back, 20, is it? And the next is plus, is it? So you pop 2 number, 20 and 18. 20 and 18, it's plus. So I have 38, is it? And I push it back, 38. Now it's the end of the expression. So you just pop this out, so it's 38, okay? So that makes sense?
Yeah.
Okay, so that's how this postfix expression works, okay? And we only have I only have 1 minute, okay, of this class. So for the other one, infix to postfix, I run out of time today. Run out of today, so we are not going to discuss starting with that new concept, okay?
I have a question about the previous algorithm we used.
Which are that postfix evaluation?
Yeah, the last one.
Yeah,
So
yeah.
So it makes sense, but how do we get that string? You see, it's not like a normal human mathematical operation. It's like already sorted in a such way. Like it was 5, 7, then multiplication, then 7, 6, 3, minus multiplication plus. How do we
Hold on,
get
let me
that?
get back. What do you mean? Can you because otherwise I don't know. What's your question?
So you had 6, 3 multiply, and then 5, 7, 3 minus multiply and plus, right?
You mean I have 3, 6, 5, 7, 3, that one?
Yeah, the string.
Uh-huh.
So the question, how do we get that string?
Oh, okay. How do you? This is an expression, is it? So there are multiple ways, depends on your application, is it? So if you write like an application, on phone, is it? You could create on phone, then you may have a text field, is it? You have text field. You can enter this. Yeah, this may be a good exercise for you guys. Okay, you can enter in the text field, is it? And then you get from text field. You have a button calculate. Then basically in the back, it apply our postfix expression evaluation algorithm, etc. And it calculated, and then over here it's the result, is it? So you can get it from text view, yeah.
So what I was trying to say that this is not like a normal human like operation, right?
Yeah.
So user won't be able to input this, right?
You mean nobody human? What? I'm sorry.
Like I am as a user, I would put like 3 multiplied by 6 minus 7 and like that, not like 5, 7, 3 minus multiply plus.
You mean human generally? Yeah, people generally use infix. Yeah, you are right. Yeah. So we call it infix expression. Is it? We use the arithmetic, so we have the parentheses, is it, and the preference order, is it? And basically, this postfix expression, machine use postfix expression to do the calculation. So later on, we will see, even though you have infix, okay, machine can convert it to postfix and then apply this postfix evaluation to calculate because it's more efficient. Is that your question?
Yeah, makes sense. So why do we need that? Why do we need the infix expression?
Infix is the regular one.
Okay, sorry, then postfix. Why do we need postfix?
Postfix, one usage. Okay, it's I here just state one usage is a machine use it to do the calculation. Okay.
All right, thank you. That makes sense.
Yeah, it's not because for infix, for machine directly to do calculation, it's kind of hard. But if machine can convert infix to the postfix, and then it do the calculation, it's more efficient. That makes sense?
Yes, I appreciate that. Thank you.
Okay. Any other questions? No questions. I'm going to stop.